Good morning, Year 4, and welcome to the first maths lesson of the week. And we are carrying on with our work of fractions, and we're looking at something today called equivalent fractions. It's a word I hope you heard about in Year 3. I think you did. May have got a bit muddled up with the first lockdown a year ago. However, that is our study for this week, and you know what? It's something which is really straightforward to get your head around, but it shows us how fractions are all related and can be used alongside each other. Okay, so to get started off, can you have a go at those questions on there? Okay, pause the video now and have a go at those on your page. Off you go. Okay, so what fraction of each of those shapes is shaded? Remember, first of all, we think about our denominator, and that's how many equal parts there are altogether. And then we say our numerator, which is a bit on top, and we say how many of those equal parts have been represented. So on this grid here, we can see that there are 9 squares, and that 1, 2, 3, 4, 5 of them have been shaded, so that's 5 out of a possible 9. 5 over 9, or 5/9. In the triangle, we've got 1, 2, 3, 4 equal parts. One of them is shaded. So that's 1 out of 4, or 1 over 4, or 1/4. We don't say 1/4. Heard a few people saying that last week. And with the circle, you can see that the whole thing is shaded. So we'd call that 1 out of 1 part, because it's just one big part, or 1. On any fraction, Year 4, any fraction where the numerator is equal to the denominator, it is worth 1, because it's the whole thing. How many sevenths are there in one whole then? How many sevenths would there be? Straightforward. That's right, it's 7. How many tenths are there in 2, or 2 wholes? Well, in one whole, there'd be 10 tenths. Get my fingers on the screen. And when we've got 2 wholes, we'd have 2 tenths. Sorry, 2 tens. 2 tens, we know, is 20. Okay? Right then, good start. Let's get on with some learning, like I said today, equivalent fractions. So equivalent, quite a fancy word, but it just means of equal value, amount, or meaning. So it means the same, or it's worth the same. Okay, so for instance, £5 coins are equivalent to a £5 note. One isn't worth more than the other, they're worth exactly the same thing. 3 add 3 is equivalent to 5 add 1. They both total the same amount. 3 add 3 totals 6, 5 add 1 totals 6. They're worth the same. And when we do about measurement and length, 1 centimetre is equivalent to 10 millimetres. In 1 centimetre, I would find 10 millimetres, wouldn't I? So they're equivalent. Okay, sometimes I talk about equivalent. I talk about hello and bonjour. Hello is English, bonjour is French, but they both mean the same thing. Okay, right, let's get on with some fractions then. So I've got a bar model here that I'm going to split into, I'm going to split into halves. And I'm going to shade in one of them. So I've shaded in 1/2. On my second bar model, I'm going to split it into what? 4 equal parts, so that each one is going to be 1/4. How many quarters would be the same as 1/2? Let's have a look. You can see there that it's 2 quarters. 1/2 is the same as 2 quarters, or we can say 1/2 is equivalent to 2 quarters. Okay, let's have a look at this next one. You'll notice on the last one that the bar models are exactly the same length. Okay, they need to be if I'm talking about equivalent fractions. There's no point having one size and one that's a different size. On this bar model then, same with one of the others, I've split it into 4 equal parts, so it's representing quarters. On my second bar model, I'm going to split it into how many equal parts now? That's right, 8 equal parts. So they are representing eighths. How many eighths are equivalent to a half? Have a think. How many eighths are equivalent to a half? Well, we know that 2 quarters are equivalent to a half, and you can see on our diagram there that 4 eighths is equivalent to a half. I want you to see, if you look at those fractions there at the bottom, look at the pattern between the numerator and the denominator. Notice that the numerator is always half of the denominator because we're representing halves. 2 is half of 4, 1 is half of 2, 4 is half of 8. Perhaps you can think of some other fractions that are equivalent to a half. On our next one, so I've got 2 bar models. The first one is broken up into how many equal parts? 3, so we're representing thirds. And the second one is split into 6 equal parts, so it's representing sixths. How many sixths are equivalent to 2/3? Have a think. 2/3 is the same as how many sixths? What do you think? Pause the video and have a go. Well, on there, we have 2/3. How many sixths would that be if I use the other bar model to represent it? I can shade them there and count them up. You can see that it'd be equivalent to 4 sixths. Well done if you got that one right. And this is where I think bar models really come into their own when we do about fractions, especially equivalent fractions. Again, we've got thirds, and this time, what have we split the other one into? We've split them into 12 equal parts, so we're showing twelfths. Remember, when you do fractions, there's a lot of spit. Twelfths. How many twelfths are the same as a third? Well, we can see there that 1/3 is the same as 1, 2, 3, 4 twelfths. If I had 2/3, that would be the same as 1, 2, 3, 4, 5, 6, 7, 8 twelfths. And if I had 3/3, that would be the same as 12 twelfths. Like we said at the start, whenever the numerator is the same as the denominator, we have a whole. When we have 3/3 or 12 twelfths, the whole thing is shaded in. Here, let's see how many we've got. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 equal parts, so we're representing twelfths. There we go, we've got 4 twelfths shaded. Have a think. What fraction is that equivalent to? There's a clue there. What fraction is that equivalent to? We can see there that 4 twelfths is equivalent to 1/3. Which is greater, 4 twelfths or 1/3? Well, we can see here from this diagram that they're exactly the same. May have different numerators and different denominators, but they're exactly the same. Year 4, pause the video now, go and have questions 1 to 4 on the worksheet. Off you go. And back to the lesson. Okay, so a conundrum now. Timmy the Turtle's come along and he said, I could use any of these bar models on the screen to show 1/2. Okay, have a think. Do you agree with Timmy? Is he correct or is he false? If he's false, can you say why? Let's have a look, shall we? Well, on the bottom there, we can show a half. Okay, 2 equal parts, one of them shaded in. With the third one there, which is split up into 10 equal parts, so tenths, we've got 5 there. Okay, let's go to the top one. We've got how many? 1, 2, 3, 4, 5, 6. There's 6 equal parts, so it's split up into sixths. I can show half of that. It'd be 3 out of 6. With the second one, though, it's split up into 3 equal parts, so we're showing thirds. But hang on, I can't shade in a half because I can't just shade in half of this block here because I'd need to shade in the whole thing. So I can't use that bar model to show a half. I can use the one above it and the one below it, but not that one. Okay, it needs to be the whole of an equal part. I can't use just some of it. Okay, it needs to be the whole part. Okay, year 4, use what we've learned there to have a go at the rest of the worksheet. Really strong confidence this week, year 4. Okay, if you're having a problem with anything, send me a quick message on Dojo and let me know, and I'll try and help out as much as I can. Great effort. Keep up the good work. Not long to go now. Speak to you soon.